Welcome back. In this lecture we will discuss beam search. So the idea behind this is let's look at what we can do in parallel. So here we'll start calling a total assignment of variables an individual. And the idea is instead of just maintaining one individual, we're going to have k individuals. And at every stage, we are going to update each individual in the population. This is often called a population-based method. And whenever an individual is in a solution, we can report this. So we can significantly speed things up this way. So like having, this is kind of like having k restarts, but we use k times the minimum number of steps instead. So with beam search, we have k individuals, but we choose the best k individuals out of all the neighbors at each iteration. So when k equals 1, this is going to be greedy descent. And the value of k is really going to set the limit based on how much memory and how easily able we are to parallelize these processes. Now, one issue this leads to is a lack of diversity, because you are essentially doing like a big parallel greedy search. So how can we overcome that? Well, the idea is to make it stochastic, of course. So it's like beam search, but it's going to probabilistically choose the k individuals in the next generation. And the probability that a neighbor is chosen is proportional to its heuristic value in kind of the same way we talked about with simulated annealing. And so now this gives us a stronger amount of diversity. And we could think of, in using some biology terminology, the heuristic will reflect the fitness of an individual in the population. So we can think of this like asexual reproduction. Each individual is just mutating over and over as we run the algorithm until the fittest one survives. So anyway, that concludes our discussion on parallel search and beam search. Please stay tuned for more content.